So this is just an example of your Mad Minute that you're going to be working on to give you some review from things that you would have learned last year. This was also on your con playlist, so you may or may not need to be looking at these, but I'm just making this for you just in case you need it. Okay, so I'm going to do 2 examples of substitution and 2 of elimination. Okay, so this is an example of substitution. So in substitution, you want to make sure one of your equations at least has a variable by itself. Okay, so in this case, both of them do. Okay, so you just decide which one that you want to move. I always choose the smaller equation, which in this case, both of these are kind of small. Okay, so this was the original. So y equals x minus 1 and y equals 2x. Okay, so when you're looking at those, you look at one of them that you want to replace. Okay, so this was my first equation. This is my second equation. So when you read this, it reads as y is 2x. Okay, so that means if y is 2x, then you're going to replace the y in the other equation with 2x. Okay, so I usually just circle it and then draw an arrow because now y is not going to be there anymore. It's going to be replaced with that. Okay, so I have replaced it. Okay, so the y is no longer there. I replaced it with 2x. So now I don't have 2 separate variables like we did in the beginning, like both of these had x's and y's and x's and y's. Now I just have x's. Okay, so I'm going to solve for x, in which most of you know how to go from there. Okay, so I would move the x over to the other side. Okay, so I'm just showing the steps. Move the x over to the other side. So 1x minus 2x gives me x. X is by itself. Okay, this cancels out and that just comes down. Okay, so now same as what we had before, when the variable is like this, the way this reads is x is a negative 1. Okay, and then you can just choose, because it has to work in both of your equations, which one you want to plug it back into. So I always just look at the one that in my mind is the easier to plug into. Okay, so I can replace this x with the answer that I just got. Okay, so x is a negative 1, so if I put a negative 1 here, because the 2 is next to the x, it means times. So I'd be going 2 times a negative 1, and that will tell me what my y equation is. Okay, or you could have plugged it into here. So we said that x was a negative 1, so if I replace this with a negative 1, then I would have a negative 1 minus 1, which still is going to give me the same answer if I went 2 times a negative 1. Okay, so I'm just showing down here, I replaced the x in either of the equations to solve for x. Okay, so if I replaced a negative 1 here, or placed the negative 1 here, okay, so then negative 1 minus 1 gave me a negative 2, or if I went 2 times a negative 1, it also gave me a negative 2. So my x is a negative 1 and my y is a negative 2. So those are my 2 answers. When you write them, the way that the answers will be written is like you would have coordinates. So the x is first, the y is second. So you put it in parentheses, and my x was a negative 1, okay, and my y was a negative 2. So this would be how you would write your answers. Okay, if you wanted to check any of these all the way through, I'm just going to show you on this first equation. Okay, if I know my answers, negative 1 and negative 2, it has to work in both of my equations. Okay, so if I were to actually plug it in to my equations, I would place my y with the number that I got and replace the x with the answer that I got. And then I just make sure the left side of my equation equals the right side of my equation. Okay, so it was a negative 1 minus 1. Well, that gives me a negative 2. Is that what my y answer was? Yes. So the left side equals the right side. Okay, or I could have plugged it into this one. Okay, so if you plug it back in and the left side of your equation equals the right side, then you know you did your answers right. Okay, so that's just to check it. You don't have to do that. Okay, so here's another example. Okay, so this is just from a different Mad Minutes. Okay, so now this is substitution. Okay, same as the last one, except we only have one of the equations that has a y by itself. Okay, so we have 2 equations. Both of them have x's and y's in them. Okay, but we're going to use this one to solve for the other one. So just like the previous one I showed you, it's y is 2x plus 2. So where the y is at in the other equation, I'm going to replace this and put this into that spot. So this is 4 times y, so now I'm going to go 4 times what now y has become. Okay, so I'm just showing you. Okay, I'm replacing this the 2x plus 2, and I'm going to put it into this equation where the y is at. So I'm putting it right there. Okay, so it's 4 times y, so now it's 4 times what I just replaced the y with. Okay, so now my equation just has x's, because that's the whole goal of substituting, is to make sure you just have one variable. Okay, so now we're going to simplify for x. So before we do that, we have to do the distributive property. Okay, so I'm going to distribute to each one of those. Okay, so x, when I distribute 4 times 2x, it gives me 8x, and 4 times 2 gives me 8. Okay, now I combine my like terms, which I have those two, so 8x plus 1x would give me 9x. Okay, so now to get the x by itself, I'm going to want to take the 8 to the other side, and when I do that, I do the opposite. Okay, so opposite of add 8 would be subtract 8. What I do to one side, I've got to do to the other side. Okay, so the 9x comes down. Okay, the 8 went away, and then I subtracted 8 from 17, which gave me 9. So now I have 9x equals 9. So to solve for x, I divide by 9 because it's multiplication, and the opposite of multiplication is to divide. So I divide by 9. What I do to one side, I got to do to the other side. So that gets rid of it. So 9 over 9 is equal to 1. Okay, so just like the last one, now I know what my x is. My x is 1. Okay, so you go back up to your original equations and just decide which one you want to plug it in for. You can plug the 1 into here, okay, or the 1 into here. Okay, I chose this one. Okay, so if I'm plugging a 1 into here, I'm going to go 2 times 1, which is 2, plus 2. So 2 plus 2 would make this 4. Okay, so my y is 4. It would work up here as well. Okay, so if I replace that with 1 and subtract 1 over to the other side, that would make 16. And 4y equals 16, and if I divide it by 4, 4 into 16 gives me 4. So it doesn't matter, whatever equation you choose, just whichever one you think looks easiest for you to solve for the other one. Okay, and so I did it into both of the equations here, so this is just showing the steps. Okay, so regardless, I got 4. Okay, so my x was 1 and my y was 4. So when I write my answers, x is first, y is second. So it's 1, 4. Okay, so that's 2 of the substitution ones. Now I'm going to go to the elimination ones. Okay, so this is an example of an elimination one. So in order to eliminate, you need to have the same number. Okay, they need to be lined up, x's with x's, y's with y's, and then the coefficient that doesn't have a variable. Okay, and then they need to be the same number. So neither one of my x's are a same number, neither one of my y's are a same number. So we need to get them to be the same number, and you just choose, because you have to solve for both x and y, which one you want to get rid of. Okay, you can choose to get rid of the x's, or you can choose to get rid of the y's. But whatever one you're choosing, we're going to have to get them to be the same number, and then one of them needs to be a negative. Okay, so in mine, I chose to get rid of the y's first. Okay, so when I decide to get rid of the y's, I look at both of those numbers and I say, okay, what can both of those numbers go into? Okay, well, 2 and 3 can both go into 6. So I want to make both of these to be a 6. So what would I need to multiply 2 by to get 6? What would I need to multiply 3 by to get 6? Okay, and when you do that, you have to rewrite the whole equation. So whatever I multiply 2 by to be 6, I have to multiply the whole equation by that. Whatever I multiply 3 by to get 6, I have to multiply the whole equation by that. And then just make sure one of them is a negative. Sometimes there already are, one's a plus, one's a minus. But if they're not, then you just choose which one you want to be. Okay, so I chose, so to get this to be 6, I'd have to multiply by 3. So the whole thing needs to be multiplied by 3. To get this to be 6, I needed to multiply by 2. And I chose this one to be my negative. Okay, so when you do that, now we need to rewrite the whole equation, not just part of it. Okay, so the 3 needs to get distributed to everything, not just the one that I wanted to change. Okay, and then the negative 2 needs to be distributed to everything. Okay, so now we have a new equation, okay, after we distribute. So I have it down here. Okay, so now I have 6x plus 6y equals a negative 6 after I distributed the 3 to each one of those. And now I have a negative 8x minus 6y equals 12 after I distributed that negative. So the whole goal was to eliminate, right? They need to be the same number. One of them's a positive, one of them's a negative. Okay, so when they're lined up, now I can start adding and subtracting. Okay, so 6x minus 8x, okay, and you can think of it as an equation. I brought it down here and it's 2x. This went away, right, because it canceled out. That was our whole goal. And now I have 6, a negative 6 and a positive 12, so that would be 6. Okay, so this is where we're at right now. So now to solve for x, I need to get rid of this negative 2. So the opposite of a negative 2 times x would be to divide by a negative 2. Okay, so when I divide by a negative 2 here, what I do to one side, I've got to do to the other side. So 6 divided by a negative 2 would make a negative 3. Okay, so x is a negative 3. So now I plug it back into either of my equations. Again, it does not matter. Okay, I chose to plug it back into this equation that was right here. Okay, so if I plug in a negative 3, and for my x, because that's what x is, it's 2 times x, so I'm going to go 2 times a negative 3, which gave me a negative 6. Everything else in that equation stayed the same, because I'm solving for y now. Okay, so the opposite of subtract 6 would be to add 6. What I do to one side, I've got to do to the other side. So I brought my 2y down. I had a negative 2 and a positive 6, which gives me 4. So I'm almost there. 2 times y, so the opposite times would be to divide. So when I divide on this side, I've got to divide on that side. Okay, so then the y's would go away. So then y is equal to 2. Okay, so my x was a negative 3 and my y was 2. So my x is negative 3 and my y was 2. Okay, and again, if you wanted to check them, remember it has to work in both equations. So you can plug your x in and your y in here and see if this left side equals the right side, or you can plug it into that one because it has to be able to work in both of the equations. Okay. All right, so now we're going to do an elimination one with fractions. Okay, and I am guessing this will be the one that everybody will skip and, of course, not watch this video to learn how to do it. Okay, so in order to get rid of fractions so that we can work with them easier, is we want to get rid of the denominator. So each one of these, we're going to look at them individual and look to see what the common denominator is, okay? And then the same thing here, whatever the common denominator of this equation is. So to do that, you want to multiply the equation by whatever the common denominator is, okay? So this one I don't have written out, so I'm going to work this one through with you. Okay, so 2, 3, and 3. So the common denominator for this one would be 6, because they can all go into 6. Okay, so I'm going to put a 6 on the outside. Okay, then for this one, the common denominator would be 4. Now, if you chose 8, that would be fine. It would still work out because you would get rid of the denominator with 8 as well. But I want the smallest common denominator so I don't have to multiply big numbers. Okay, so I'm going to put a 4 on the outside. Okay, when I distribute to each one of these, the whole goal is to get rid of the denominator. Okay, so 2 goes into 6 3 times. So really it's not 6 that I'm distributing, it's 3 that I'm distributing to the numerator, which gives me 3x. Okay, and if that totally confused you, I just did a shortcut, because if you multiplied this times this, this would be 6x over 2, right? And 6x over 2, you can divide 2 into 6, which makes 3x. Okay, so it's just saving us one step by not having to write these out. Okay, so the bottom number goes into 6. Okay, so 3 goes into 6 twice. Okay, so you distribute 2 to whatever was left at the numerator. So 2 times a negative y is a negative 2y. Okay, and then the last one, 3 goes into 6 twice. Okay, so 2 gets distributed to whatever's at the numerator. So 2 times a negative 1 would make it a negative 2. Okay, so now let's do the next one. 4 goes into 4 one time. Okay, so 1 gets distributed to the numerator, so it's just a 1x. 2 goes into 4 twice, so 2 gets distributed to whatever's at the numerator, so that'd be a negative 2y. Okay, and then 2 goes into 4 twice again, so 2 gets distributed to the numerator, so 2 times 3 would make 6. Okay, so now we're just at what the problem we just did where we had elimination. Okay, in the previous one, you're just choosing which ones you want to get rid of. Okay, glance to see if any of the numbers are the same. Okay, if you don't catch that, then you could just say, okay, well, I'm choosing to get rid of the 3s, so I would multiply this by a negative 3 so that I would have the same number going, but you have to distribute it to everything. To me, this stood out because the numbers were the same, but they're both negative. So I need to make one of them a positive. So to make this change into, or this one, it doesn't matter, I'm going to change this one. Then I just need to multiply the whole equation by a -1. Okay, so when I distribute that, now I only have to change one of my equations versus two of the equations. So if I distribute that to that, that would give me a -3x. When I distribute this to this, a negative times a negative changes it to a positive. And that's what I wanted, because I wanted it to be the opposite of that. Okay, and then a -1 to that one, so that would be a +2. Okay, I didn't have to change this one, so I'm just going to bring this one over so that they are lined up. Okay, I eliminated my y's, so it went away. So I have 3x and a 1x. Okay, so that would give me a -2x. I have a +2 and a -6, so that'll give me 8. Okay, and then I divide by -2 to get rid of the x. Divide by -2, that goes away, so x is equal to a -4. Okay, so I have one of my equations. Okay, now I don't want to have to go back to my original because I don't want to work with fractions. You can if you want to. So I'm going to go back to the equations that I just had, that I just wrote. Okay, or you can even go back to this one or this one. Okay, because this equation is the same as this one. Okay, and this one's the same as that one. Okay, so x is a -4. So I'm going to plug it into this one right here because that looks a lot easier to me. Okay, so it's 1 times x. Okay, so 1 times a -4 minus 2y equals 6. So 1 times a -4 would give me a -4. Okay, so to solve for y, I'm going to move this over to the other side. So the opposite of subtract 4 would be to add 4. Okay, so that goes away. So now I have a -2y equals 10. Okay, so to get the y by itself, I need to divide by a -2, divide by a -2, so y is equal to a -5. Okay, so my x is a -4, and my y is a -5. Okay, so again, if you wanted to check it, say if I wanted to plug it into this equation, I already knew it worked for this one. So if I plug in a -4 here, a -3 times a -4, well, a negative times a negative is a positive, right? And that gives me a +12. And then if I plug in my y, 2 times a -5 would be a -10. Does my left side of my equation equal my right side? Well, 12 minus 10 is 2, so 2 equals 2, so I know it works. Okay, so that is my answer for that one. Okay. All right, good luck. Remember, I want to see your work, so when we go to grade these, we can see maybe where you messed up. Okay, so that'll be part of your points. Okay, see you tomorrow.